Okay, before we put the Gilbreth principle behind us for now, I thought we would actually do the third and final presentation or performance by Max Maven. And I will go ahead and narrate it as I've done before so that I can focus on the aspects of the performance that are the most important to us. So he's asked for two volunteers, one who can riffle shuffle a deck of cards, and one who can type into a computer, knows how to type on a computer. Okay, so he says what he's looking for is something more than just a card trick. He's going for something much bigger. He wants to address the question of finding an answer to the ultimate question of life, the universe, and everything. So he has a deck of cards. He never actually touches the cards themselves. He gives it to the volunteer. And he asks him to cut the cards roughly in half. And then after the cards are cut, he gives this volunteer the option of flipping over either half of the deck on the table. And once he has flipped over half of it, he's asked to then riffle shuffle those together. Okay, so think about what's happening. So he started with a deck that he had not even touched. The spectator cut off a number of cards and flipped one half. What does that do to the order of the half that was flipped? Does it not reverse the order? Okay, so keep that in mind. And now he riffle shuffled them. Okay, now he's giving him a series of choices. He's asking him first, would you like to work with the deck as it sits on the table, or would you like to flip it? And the spectator chose to flip it. From here, he gives him a number of choices. He says, well, we need 6 cards. And those 6 cards could be chosen to be the top 6 cards, regardless of whether they're face up or face down. Or it could be the top 6 face-up cards or the top 6 face-down cards. The spectator decides to go with the top 6 face-down cards, which he's dealing into a separate pile. And then Max Maven says, well, your job now is to add the values of the cards that you have now chosen. Okay. He's also reviewing all of the decisions that were made by the spectator. Namely, he cut the deck at the beginning, he chose which half to flip, he riffle shuffled them, he decided whether to work with the deck as it sat on the table or to flip it, and then he even chose which 6 cards to select, either face up, face down, or just consecutive. Now he's going through and he's counting up the values of the 6 cards that he freely chose. And that total comes out to be 42. Now he asks the second assistant to type into Google, what is the answer to life, the universe, and everything? And Google responds, 42. 42 is the answer to life, the universe, and everything, which is exactly the total of the cards that were freely chosen. How in the world was this done? How could you guarantee that these 6 cards would add to 42 after the deck had been split in half, one half flipped face up, those 2 halves riffle shuffled together, and then you're free to work with the deck as it stands or flip it, which is what the spectator did, and then you're free to choose either the top 6 consecutive cards, whether they're face up or face down, or the top 6 face up cards, or the top 6 face down cards. Well, the spectator did that, making free choices, and the 6 cards he just happened to choose indeed added up to 42. As you might imagine, the cyclic packet needs to be constructed. Now, it ends up that there are many ways to construct a packet that will allow us to finish with the conclusion shown here in the performance, okay? So what I've done here is I've just identified a particular sequence of values for our cards that would work. So we follow the standard convention that a jack counts as 11, queen is 12, king is 13. So here we are counting a jack as an 11. Well, if you add up these values, you'll find that they add up to 42 as desired. So it should be clear that if we're going to use these values, we may need to use cards from more than one deck. Because right now we have 6 distinct values. Each of those come in 4 suits, so that would only give us 24 cards if you draw from a single standard deck of cards. Okay, so that's the first thing to know. For this to work, we would actually have to draw from 2 decks of cards, which is what I've done here, as you'll see. So the thing to do is just simply put out all of the 9s from 2 decks of cards. There'll be 8 of them. All of the 5s, 6s, 8s, 3s, and the jacks. And then the thing to do is you pick up one of the 9s. Now you may want to randomize these within each value group, just so you get a good mixture of colors and suits. So you'd pick up a 9 and you'd put it in your hand, and then a 5, 6, 8, 3, jack. And then a 9, 5, 6, 8, 3, jack. And you would do that for a total of 8 cycles of length 6. Well, it is true that that gives us a total of 48 cards, not 52, but only the astute observer would detect the difference between a packet of 48 cards versus 52. Okay, so I'm sure that was not noticed by the participant. Okay, so let me show you that I've actually set up a packet with that structure starting at 9, 9, 5, 6, 8, 3, jack, 9, 5, 6, 8, 3, jack, and then if you follow through, you'll see that I follow that pattern of 9, 5, 6, 8, 3, jack. And I have a total of 8 cycles of length 6. Okay, now if we carefully gather this, now in the case of Max Maven, is he put it in the packet, just like so, and then he just brought out the packet. He said, okay, here's a packet of cards. I won't even touch the cards. Can you carefully draw out all of the cards? Make sure you don't leave any in the packet. Nope, looks like we're good. He asked the spectator to cut the deck in half, or fairly close to half. There you go. So it's cut in half. So we have a cyclic structure. It has 8 cycles of length 6 each. Now, the participant is allowed to flip over either half. We'll flip over this half, let's say. So what does that do? When you flip over that packet, what does it do to the order of the cards? Well, it reverses the order of those cards. So that now if we riffle shuffle these together, the action of flipping over one of these packets and then riffle shuffling those together would constitute a Gilbreth shuffle. Okay? So that would constitute a Gilbreth shuffle, even though we haven't seen one like that yet, right? Okay, so let me just kind of riffle shuffle those together. I'll just show you that, in fact, it's not the best shuffle in the world. So it's far from a perfect shuffle. Okay, and then we just bring those together. Now, at this point, Max Maven gave the participant the chance to work with the packet as it sits right now, or to work from the other side. Now, he actually chose to work from the other side. Great. So that's the side from which we will be looking for our 6 cards. Okay, so let's kind of just think through some of the properties of this packet here. What properties does it have? And one of the properties it has is a consequence of the Gilbreth principle. But two of the other properties it has, which are essential to this performance, have nothing to do with the Gilbreth principle and everything to do with the fact that it was cyclic to begin with. Okay, so if the participant had chosen to just go with the top 6 consecutive cards, regardless of their orientation, that would mean that he would have selected this one, 2, 3, 4, 5, 6. So I'll just carefully take these off. I'll be putting them back in the same order. So he would have grabbed these. So these are the top 6 consecutive cards. Okay. Now, by the Gilbreth principle, what do we know will have to be true about the identities or the values of these cards? Okay, so remember, we started with a cyclic structure where we had cycle length 6. We had values within each of those cycles that add to 42. That's how it was constructed. Okay, so the Gilbreth principle says that if you take that cyclic packet that has cycle length 6, you reverse count a number of cards, doesn't even matter how many, you reverse count, riffle shuffle those together, the ending packet will have the following structure. If we take groups of 6 cards from the top and move down the deck, every group of 6 consecutive cards from the top of the deck will have one of each of the values in the cycles that we constructed at the beginning. So we have here a jack, a 3, an 8, a 6. So by the Gilbreth principle, these 2 remaining cards would have to be a 5 and a 9 in some order, and we don't know the order. So there's the 9, and that would leave the 5. Okay. So we know this by the Gilbreth principle. Without the Gilbreth principle, we would not know that this is the case. Okay. So let me just carefully kind of put those back to, where they were. Okay. So the conclusion would have been reached, or the desired outcome would have occurred if the spectator had chosen the top 6 consecutive cards. Now, what about the top 6 face-up cards? So that would be the Jack, 3, 8, 6, and then the next 2 would be the 5 and the 9. So why are we guaranteed that those values would add up to 42? Well, it's because the up-facing cards here are in the exact original order from the 2 cycle that we built at the beginning, right? So like 9, 5, 6, 8, 3, Jack, 9, 5, 6, 8, 3, Jack, 9, 5, 6, 8, 3, Jack, and so forth. So remember, the up-facing cards came from flipping one of the halves at the beginning face up. Well, that just reverses the order, the overall order of the cards in that packet, but it doesn't upset the relative placement of those cards in relation to each other. And so you will get this perfectly cyclic pattern for the up-facing cards. Well, the same thing is going to be true for the down-facing cards. They will also be in a perfect cyclic order, determined by the original structure of the cyclic packet that we created. Okay, so here we go, 9, 5, 6, 8, 3, Jack, 9, 5, 6, 8, 3, Jack, and so forth. So no matter what cards the spectator chooses, either the top 6 consecutive cards or the top 6 face-up cards or the top 6 face-down cards, we are guaranteed that the cards arrived at by one of those 3 choices will add up to 42. So that is Max Maven's third performance.